Welcome back to another video on the channel. In today's video we're going to be taking a look at question 22 from the Physics External Exam for Paper 1, 2021. Now, if you have any questions at all during the video, leave something in the comments and I'll try my best to answer it. And as you would have noticed on the channel, I've started splitting up the questions into individual videos. That way I can go into a bit more depth on each question, and also allows you to have a bit more study material. So pretty much if you only struggle with certain types of questions, you can go watch those in the corresponding playlist. If you guys want a Physics External Exam bundle pack, the link is in the description below. And now there is also a bundle pack which you can get the Physics, the Specialist Math, the Math Methods, and the Chemistry one for pretty much the price of 3 rather than paying for 4 of them. So that's also available as well. Otherwise, let's get straight into this question here. So, question 22 worth 3 marks here. A planet is orbiting a 3.38 times 10 to the 31 kilogram star. The radius of orbit is that many kilometers. Calculate the average speed of the planet. Okay. Now, this question is a little bit tricky to understand. What we've always got to do when we have physics questions though is to work out what we have and work out what we need to find. So in this question here we're given the mass. Okay. So we're given mass equals 3.38 times 10 to the 31 kilograms. Now we're also given the radius, okay, at which it's orbiting. Now notice it's in kilometers, okay. We will need to convert that a bit later to make sure it is in SI units. They did that on purpose, okay. Now we are after the average speed of the planet. So we're talking about like velocity here. So we've got a planet and a planet is orbiting a star. Let's just go, we can leave that as the star then. Let's say the planet is here and it's orbiting like so. Now we know that distance, assuming it's from the center of the star to the center of the planet, we know that distance is r, and we know the mass of the star is that there. Now what we can do in this situation here is we can assume two things. Even though the orbital path usually is elliptical, in physics we can assume it as a circular path, which means we could use circular motion here if we do want to. Now what we've also got to realize is the two things that we'll have in common in this question. Well, for starters, we've got two bodies. We've got this mass and this mass here, but we're only given the mass of the star. We don't need the mass of the thing orbiting it because we can cancel it out. There will be a force of gravitational attraction between these two bodies. There's also going to be a centrifugal force because it's a circular motion between them. So here we can actually equate, basically saying the centrifugal force is equivalent to the gravitational force. Now centrifugal force is given by this formula here in our data sheet. Mass is velocity squared over the radius at which it's orbiting. The gravitational force between two bodies is gravitational constant times the mass of one body times the mass of another body over the radius squared, or the distance between them squared, basically. Now, in this situation here, because they're equivalent, because we can assume it's a circular path and the centrifugal force will be in the same direction as the gravitational force, we can equate these two formulas together, which allows us to get this. Mass times velocity squared over the distance between them is equal to this guy here. Now here's the good thing. You can cancel out one of the masses, and the mass that we'll be cancelling out is the mass of this guy here. So we can get rid of that guy there. We can also cancel one of the radiuses as well. So here we can get rid of that and turn it to a power of 1. So now we have this. Velocity squared is equal to gravitational constant times the mass of the star over the distance between them. So when we're doing this now, let's just list what we have and what we don't have. We have the mass right there. We have the distance right there. And we also have the gravitational constant. It is in your data sheet as well, or your data booklet. I'm just going to pull it up very quickly because I don't remember it 100%. So G, if it's on the back page, is 6.67 times 10 to the negative 11. Okay? So here we can solve for velocity. Now, we've got to make sure we put this in SI units, okay? Because this is in meters per second. That is in kilometers. Kilograms is fine because that's SI units. So here we've got to think, all right, 1 kilometer is 1,000 meters. So you need to times this number by 1,000. Now, when you times that by 1,000, you've got to think how many decimals are you moving that across. Now, 1,000 technically you're moving across 3 decimals. So here, we can just add 3 to the 8 here. So the radius is 4.23 times 10 to the 3 plus 8 would give you 11 meters. Now we've got everything we need to answer this question now. Okay, so let's get rid of that stuff there, and we don't need that anymore. So now we can just chuck it in. Now here, to get the velocity by itself, you would also have to square root both sides to undo that square. So you have this now. Okay, now you can just start chucking everything in. And again, this is assuming we've done everything correctly. I think we have in this case here. If not, I'm sure someone will bring it up in the comments here. 6.67 times 10 to the negative 11 times by the mass, which is 3.38 times 10 to the 31 over the distance, which is 4.23 times 10 to the 11. And then we just chuck this into our calculator. So I'll do it so. But here, notice in the question, you have to have it rounded to the nearest number. Okay. So if we go like this, 3.38 times 10 to the 31, and 4.23 times 10 to the 11. So we're going to get a velocity which is 73004.7. So when they say round to the nearest number, it's going to be 7300, and I'm going to round that up to a 5 there. And that would be it. Okay. If you have any questions about this one here, leave something in the comments. If you guys want the Physics External Exam Bundle Pack, the link is in the description below. And if you want the link to the whole playlist, it's also in the description below. But otherwise, I'll see you guys in the next video.